All right, so our grand finale is 7.3. We've been doing all this to work up to being able to solve systems of linear equations using matrix algebra. So that involves using our inverse of square matrices also. Notice this only works if we have a unique solution. It only works if our matrix is square, so we have the same number of variables as we do equations. All right, so solving a linear system using a matrix algebra, we have, if we have our system that looks like the coefficient matrix times the variable matrix equals the coefficient matrix, then I can solve that. I'll leave some space here. I can solve that by taking the matrix, the inverse of the coefficient matrix, because then these on the left will turn into the identity matrix, and on the right, I get that, and the identity matrix times x, anything times identity is itself. So that solves for our, that gives us the way to solve for the variables. Okay, so I'm gonna ask you to pause my video, go to your textbook, and watch example 7. This is a bit of a longer process, so that's about a 15-minute video, and I'll show you this example from 7.3. It's a bit longer, as you can see from your textbook, but it walks through how to do it. So here's our, watch that lecture video, 7.3, example 7. This is in your pre-lesson also, so you may have already seen it, in which case, if you feel comfortable, then you can move on to trying our example. But watch that for our how-to. Okay, so now you've seen an example of that. I'd like to ask you to try number 40 now for a practice problem. So go ahead and pause the video again, try number 40, and then you can play this video again to check your work. Okay, so our first step, this has a couple different steps. From our very first section, 7.3, 7.3.1, we learned how to convert this into an equation matrix. So I take my coefficients of x, y, and z, x, y, and z, x, y, and z. So I have my 3 equations, my 3 variables, so I have a 3 by 3. And I have x, y, and z are my 3 variables. When I multiply those two together, I end up getting these equations. And that equals the coefficients. This is a 2, not a z. And now that sets up the equation, the coefficient matrix times the variables equals the coefficient matrix. So that's what we talked about up here. So in order to solve for x, we need to find the inverse of a. So we get a inverse times b. And that will give us our xyz matrix. Okay, so to find the matrix, find the inverse, that was 7.2.2. So to find the inverse of a, remember that the inverse, if we take a augmented with the identity matrix and convert that to the identity, use the row operations to convert it to identity matrix augmented with another matrix, then that new matrix on the right becomes our inverse matrix. So we're going to do that. So starting with A on the left, our matrix A is 1, negative 1, 1, 1, 1, 1, negative 1, 2, negative 3. And, whoops, I don't want to close it. and we're augmenting it with a 1 identity matrix that's 3 by 3. So that's 1s down the diagonal and then 0s everywhere else. And we're going to do some row operations to get the identity matrix on the left. So in that first row, I already have a 1 here. So that row is all set. Row 2, I want this guy to become a 0. So I'm going to subtract row 1. So I'll go row 2 minus row 1. And here I want this guy to become a 0 too, so I'll take that row and add row 1. And I get row 1 doesn't change, so I'm just going to write that in first. And then row 2, subtract row 1. So 1 minus 1 gives me 0. 1 minus negative 1 gives me 2. 1 minus 1 gives me 0. 0 minus 1 gives me negative 1. 1 minus 0 gives me 1. And 0 minus 0 gives me 0. Okay. Now row 3, I'm adding row 1. So I get that first 0. So I get negative 1 plus 1 gives me 0. Then 2 plus a negative 1 gives me 1. Negative 3 plus 1 gives me negative 2. 0 plus 1 gives me 1. 0 plus 0 gives me 0. And 1 plus 0 gives me 1. All right. So now my first step is done. Going downstairs, I need to get to my second step. I need to get that 2 to be a 1. So for my next matrix, I'm going to do let's see, row 1 I'm not going to touch. But row 2, I want to divide by 2 to get that leading 1. So I'll take 1/2 of row 2. And row 3, I want that to get to be a 0, but I'm not ready to do it yet because I need the row above it to be a 1. If I try to use the first row, I'm going to lose that leading 0 that I got in the last step. So I'll just go ahead and wait on that. So I'll just copy row 3 as it is for now. And I get 1, negative 1, 1, 1, 0, 0. So row 1 and row 3 are not changing, so I'm going to copy those first. And then row 2, I take half of everything. So 0, 2 divided by 2 is 1, 0, negative 1/2, 1/2, and 0. All right, so now row 1 is still looking good, but going down my step where I'm still my second step, I got my top 1, but now I need this guy to be a 0. So row 1 and row 2 will stay put, and row 3, to get that to be a 0, I can subtract the row above it. So that's row 3 minus row 2, which gives me, let's see, row 1 and row 2 don't change, so I'll just copy those down right away. Whoops, sorry, I went too fast there. Now for row 3, I want to subtract row 2, so I go 0 minus 0, I get 0. 1 minus 1, I get 0. Negative 2 minus 0, I get negative 2. 1 minus 1/2 is 1 plus 1/2, which is 3/2. And then 0 plus 1/2 gives me 1/2. Oh, I'm sorry, I'm subtracting. 0 minus 1/2, sorry. It was negative 1/2. And then 1 minus 0 gives me 1. All right, now row 1 and okay, so I'm just going down my steps. I got my second step done. Now my third step. That means I need to make this guy a 1. So I'm going to take my next step, row 1 and row 2 stay put. Nothing changes there. But row 3, I want to take a negative 1/2 times row 3, so I get my leading 1. So row 1 and row 2 don't change, so I'll just copy them down. And then row 3, I want to take a negative 1/2 of it. So that gives me 0, 0, 1, negative 3/4. Half of 3/2 is, so I multiply by 1/2, so that becomes a negative, and then denominator of 4. And then negative 1/2 times negative 1/2 gives me a positive 1/4, and negative 1/2 times 1 gives me a negative 1/2. All right, so I've gone downstairs. I got my reduced row echelon form, so now I got to go back upstairs to get zeros all above the ones. So I already got this one, so that one's good, but I still need this guy. So to turn that one into a 0, what shall I do? Let's see, if I subtract row 3, row 1 minus row 3, then I won't hurt the leading 1, and I'll get a 0 in that third spot. And row 2 and row 3 are actually already set, so I'm not going to do anything else to those guys. So I'll copy row 2 and row 3 because they're perfect. And then row 1 minus row 3. So that's 1 minus 0. And then negative 1 minus 0. And then 1 minus 1. And then 1 minus negative 3/4. So that's plus 3/4, which gives me 7/4. And then row 1 minus row 3, so 0 minus 1/4 gives me negative 1/4. And 0 minus negative 1/2, so that's plus 1/2, which gives me 1/2. All right, we're almost there, so we're still going up our stairs. We got the first step going upstairs, and now going on to the second step going upstairs means we got to take that guy and make him a 0. So I will add row 1 and row 2 together. That will turn them into a 0 and not hurt the work we've already done. So row 1 plus row 2. And row 2 and row 3 are perfect, so I'm just going to copy them down. So 0, 1, 0, negative 1/2, 1/2, 0, 0, 0, 1, negative 3/4, 1/4, negative 1/2. Just copying row 2 and 3. And then row 1 and 3, I'm going to add them together. So 1 plus 0, negative 1 plus 1, 0 plus 0. 7/4 plus 1/2 is 7/4 minus, plus negative 1/2. So that's 7/4 minus 2/4, getting a common denominator. That gives me 5/4. And then 1/4, negative 1/4 plus 1/2 is negative 1/4 plus 2/4, so that's 2 minus 1, so that's 1/4. And the last one, 1/2 plus 0 is 1/2. So I'll erase my scratch work. And I got my identity matrix on the left. Remember, this is the identity, and then A inverse is now on the right. So that tells me that A inverse is negative 5/4, 1/4, 1/2, negative 1/2, 1/2, 0, negative 3/4, 1/4, negative 1/2. And multiplying that by R, so I'm going to go back a little bit here. Remember what we're doing here. So we have our, where is it? This right here. We're plugging that into there. So, sorry, so I should do that. So that's my A inverse. Now to find x, I take my A inverse and multiply it by b. And remember, b is the 0 to 1. So I'm going to take that A, I'm just going to copy it down. And multiply it by b. Sorry, I'll just move it over here. And multiply it by b, which was 0 to 1. That will give me the variable matrix x, y, z. All right, so multiplying those together, what do I get? Let's see. So I have a 3 by 3 times a 3 by 1. Those centers match, so that means there is a product, and the product will be a 3 by 1. So when I multiply these together, I'll end up getting a 3 by 1. I'm going to make it a little wider just because I want to be able to show my work in it and then simplify. So remember, our 3 by 1, our top element then is going to be first row on the left times that column. There's only one column, so it will only end up with one column. That's the 3 by 1. So we get negative 5/4 times 0 is 0. 1/4 times 2 gives me 2/4, or 1/2. And the 1/2 times 1 gives me 1/2. So that's my first element. And my second element, we'll do second row times the column, and we get 0. 1/2 times 2 gives me 1. 0 times 1 gives me 0. And then the third row times that first column, and we get negative 3/4 times 0 plus 1/4 times 2, so that's 2/4, or 1/2, and negative 1/2 times 1, which is minus 1/2. So I get x, y, z equals 0 plus 1/2 gives me 1. I'll do it in green. And the 0 plus 1 plus 0 gives me 1. And the 0 plus 1/2 plus 1 minus 1/2 gives me 0. So that gives me my solution matrix, which tells me that x equals 1, y equals 1, and z equals 0. So there's my solution, or I could do an order triplet that says 1, 1, 0.